Welcome back. This is Further Solutions Academy. Further Solutions Academy. Encourage us more. Help us to share our video and also subscribe to our channel. Help us to share and subscribe to our channel. In this video, I'll be walking you through problems on limits. I think our previous video I've defined limits, I've explained left hand side and right hand side, and also I've done property of limits. But this time around, I will be showing one or two problems on limits that will really help us to handle limit problems. Now, I've explained what is called left hand side and right hand side. One is positive increase, one is negative decrease. That is just the logic behind it. There will be increase. It means like the positive and negative. Now, when I have a problem this way, I'm asked to find the right hand and left and the left. And limit of a function defined as follows. Now I have my f of x equals to, now I have x minus 4 divided by x minus 4. This is absolute value. For x is not equals to 4. And this one is x, which is what? For x equals to 4. It means when my x equals to 4, when my x is limited to 4, it will be equals to 0. That's what I mean. Now, for not equals to 4, that is what I'm to work on. Now, solution to this problem. There are two things here. The first thing is my x equals to 4. Once my x is limited to 4, which is equals to 4, it will surely be equals to 0. Now, but when my x is not equals to 4, that is where we don't know what will happen. That's what I want to work on. It means when my x is not equals to 4, when my x is not equals to 4, two things will happen here, which is two or more things can happen, 3 or 4. Let me just, inequality comes to play. This one is equality, this one is inequality. Now, here, it means inequality comes to play. It can be great, it can be less, it might be greater than equals to, and can be less than equals to. Now, let's see how it will come. Now, the first one, now, when my x is greater than 4, when my x is greater than 4, it means what I'll be doing there is that my absolute value of x, it will be equals to x minus 4. Now, when we talk about absolute value of a particular function, okay, I think I've explained that in a previous video. Now, since I have that, I can have that what? My limit of x tends to 4 positive. Okay, let me just use the word 4 plus is 0. It means my 4 is increasing. It will be equals to, because it's greater than what? It will be equals to bracket of, what is my limit? I mean, absolute value is equals to x minus 4 divided by x minus 4, close bracket. Now, which I will surely have, which it will give me 1. Now, it will give me 1. It means limit of x tends to 4 positive plus is 0, it will be what? 1. Which is, if I limit it to be, my limit will be equals to 1. It means that is equals to 1. Now, the second one is when my x is less than 4. The first one is when my x is greater than 4, I'll be having 1. Now, when my x is now less than 4, that's what I want to work on now. Once my x is less than 4, it means this absolute value of x minus 4 absolute value of x minus 4, it will be equals to minus bracket of what? X minus 4. That is the meaning. It means we are playing around on the down part of the function. Now, equals to 4. Now, I will now move on by having my limit of x tends to x4 minus 0. It means down part of what? Of that function, which is, it will be equals to, of a limit of minus x minus 4 divided by x minus 4. Limit, this will cancel this. It means I have limit of x to 4. It will be equals to minus 1. Oh, sorry, minus 1. Which is, my answer is minus 1. My answer is minus 1. It means at left and right, we are talking about what? 1 to what? To minus 1. That is the main limit of a function. It means if I want to do it very well, to show that I know what I'm doing, I can say minus 1 less than equals to s, less than equals to what? 1. That is the function. That is where the function exists. Okay, that is just where the function exists. Now, the function may not be after a number above this. It means the number does not exist. But the next option, the next example, will help us to understand when it exists or not existing. Okay. I have this problem also. Before I talk about this problem, I want to let you people know when my epsilon, my exponential its powering is 0, when my exponential is powering minus infinity, and when my exponential is powering infinity. These are very, very important at this point because we have to understand this. When my exponential is powering 0, is always equals to 1 because we are told that any value raised to power is 0 equals to what? Anything raised to power 0 equals to 1 except 0 himself. Now, when this is equals to, this can be written as e of infinity. Now, which also can be equals to, when I have it this way, it means when I have 1 all over infinity, e raised to power infinity is always equals to infinity. And if I have it this way, this one will give me 0. This one will give me 0. It means this one will just tell me 1 all over what? Infinity. 1 over infinity is equals to what? Is equals to 0. That is what we are talking about. Now, with what is here, it will help us in our next example. Very, very important. Please take note of that information. They are very, very important. For instance, let me generate a question that can help us. Okay, evaluate. Evaluate 1 divide 1 plus e raised to power 1 over x. Now, I want to evaluate this question. It's a very nice one because I've explained what is epsilon is talking about. What exponential is talking about when it comes to power. Now, take note of this solution to this problem. What I want you to understand here are very, very important. You have to understand this as s approach to positive is 0. It means increase. We feel it will be feel that 1 over x increase indefinitely. Now, when we have as s tends to this, it means this will be increasing definitely. To be increasing. But now, okay, that's the first one. E raised to power 1 over x increase indefinitely. No, this one is definitely. This is definitely, sorry, definitely. Now, this one will now be increased indefinitely. Indefinitely. Now, it means e raised to power minus x tend to 0. Now, 1 plus e raised to power minus 1 all over x tend to 1. Now, thus, they require limit may be 1. Maybe 1. That is just very important. Please take note of this information. They are very, very important. That is very, very important. Now, I've established that the limit is tending to 1. It means I can say that 1 divides 1 plus e raised to power minus 1 over x minus the limit, which is the limit is equal to what? 1. Absolute value of less than epsilon. Less than epsilon. Now, just take note, when my 0 less than x less than delta, please take note of, we have done this in our last video. When my x is less than this and less than delta. Now, what can I do next? I want to work on this part. It means I can say that 1 all over 1 plus e raised to power minus bracket of 1 minus plus e raised to power 1 all over x. What I'm trying to do is I'm finding LCM, which is my LCM comes to play. My S comes to play. Now, absolute value, which this will be equals to minus e raised to power divided by 1 plus e raised to power. Okay, now it will be less than, which is the absolute value equals to less than what? Epsilon. Less than epsilon. Now, since I have it this way, I cannot continue when e of x, raised to power plus this plus 1, it will be greater than 1 all over epsilon. 1 over epsilon or 1 all over x. Now, also greater than ln or log. Okay, let me use ln, which is ln function of 1 all over epsilon brackets of minus 1. It means all the function here, what is here, everything that is here is being represented by what? By the epsilon, which is the epsilon. My epsilon is equal to what I'm trying to say there. Now, since I have it this way, I can, which implies, that 0 less than x less than 1 all over, what is here? 1 all over ln of 1 all over epsilon minus 1, which is also for all is 0 less than x less than 1. Now, since I have it this way, now let's choosing my 1 all over ln function, ln of 1 all over epsilon minus 1, which if is 0 less than x less than 1. Now, if less than 1, okay. Less than 1, okay. I can now continue by having, okay, I have that back to normal problem, which is 1 all over 1 plus e 1 all x minus 1 epsilon, absolute value less than epsilon when 0 less than x less than delta. Less than delta. I've told you the meaning of delta, which is epsilon and also. Now, since I have, now when my epsilon greater than equals to 1, when my epsilon is greater than equals to 1, it means I'll be having absolute value of 1 all over 1 plus e exponential function minus 1 absolute value. Now, we have established this, that this, from our first statement, that this is tending, this is tending to is 0. Now, it means this is tending, what is there? What is here is telling us that it's tending to epsilon, which is less than epsilon. Okay, it's less than epsilon. Now, since I know that, it means my e raised to power x will be greater than 1 over e minus epsilon. It will be greater than 1 over e minus epsilon. Now, since I have it that way, I think that is my function. That is all what I need. That is what I need from that. Now, my e is equals to this, which is less than epsilon, and this is equals to this, which is greater than this, which is exponential is being represented on what is here. Epsilon is being represented here minus this. That's all what we have. Now, by so doing that, I think I can continue by saying that okay, I can continue. Yes. Okay. Now I can continue if it is true. If okay, it is true for all value of x, so that any delta greater than 0 will work. Stop. For any epsilon greater than 0, we are able to find a delta greater than 0 such that my 1 all over 1 plus e raised to power 1 over x minus 1 absolute value will be less than epsilon when 0 less than x less than delta. Okay, it means limit of s tends to 0 positive will be equals to 1 divided by 1 plus e raised to power minus x, which is it will be equals to 0. Now, we have done that before, because when we do this earlier, the limit of this, when we do this, is equals to 1, which is, we have done that at the beginning of the statement. It means 1 minus 1, it will be equals to what? 0, which is when you limit this to, which is I will be having, what I'm trying to do. Let me quickly put more light there, because for those that are still learning. Now, it means I'll be having, I want to limit this function, forget this is 0 for now. It means I'll be having 1 all over 1 plus e raised to power 1 all over 0, which is this, which is I'll be having this. It will be equals to minus 1, which is, I'm talking about absolute value of that, which is this 1 all over 1 minus plus 0 minus 1, which is going to be 1 minus 1, which is equals to 0. That is what I'm trying to say. That is why that becomes 0. Now, let's move on to the next one. Let me give more example on this part. Okay, evaluate limit of, evaluate the following. Let me just do the following. Okay. Evaluate 1. Limit of x tends to 0 positive, x minus absolute value of x plus x, which is equals to, we don't know it. And 2, limit of x tends to 0 negative, which is x minus x absolute value plus x, which is, we don't know it also. Now, we have this type of problem to work on. How do we work on it? Number 1, we must know what is on ground. The first thing is what? This one is left, one is right. It means I can see the solution to this problem. What I will do first is, okay, what can I do to make this thing, my absolute value, it will be equals to, this one will be what? My x. When my x is greater than 0, this one will be what? Is 0 when my x is equal to 0, and also x when my x is less than 0. These are the possible things that can happen. Now, I will now continue by having limit of x tends to 0 positive. It means I'll be having, it will be x all over absolute value of x plus x, which it will be my x is greater than 0. Since my x is greater than 0, which it will be also equals to x. Since my x is greater than 0, I'm having x. It means I'll be saying that what? Limit of x positive, x all over x plus x, which is this one will cancel, be 1. Limit of x positive will be 1 plus x. Now, can I limit? I will limit my function now. It means 1 plus 0, which is equals to 1. Now, that is the first one. The next thing is when my x is other part of it, which is when my x less than 0. When my x is less than 0. This one is absolute. It means it will surely be 0, 0, 0, 0, and add up every 0 to be equals to 0. Now, when my x is less than 0, which is equals to what? Minus x. It means I'll be having the limit of x minus negative bracket of what? X minus x plus x. This will cancel, which is going to be minus 1 plus x. Limit of x tends to infinity positive, negative. Now, which I will be having minus 1 plus 0, which is equals to minus 1. That is all. That's all what we need there. It means for example, minus 1 and plus 1. And with this, I've explained left and right limits. With this example, first example and second example. Okay, thanks for watching.